Continuing on with the inflammation or the inflammatory reaction, we know it's triggered when there's an injury or an infection through the release of chemicals called inflammatory mediators. Here they call inflammatory chemicals. An example of an inflammatory mediator is a histamine. Now, sometimes we take antihistamines to block this, especially if it's something like an allergen, something like pollen or something that creates this, because pollen's really not going to hurt us, but yet we're going to go through all these symptoms of our body trying to handle the pollen. So sometimes we will take antihistamines to block this, but really we wouldn't want to take antihistamines if we actually had an infection, because we actually want the body to go through this process as long as it doesn't overdo the process. And as in something like anaphylactic shock is when this whole process is going on and we would have this capillaries all over the body becoming more permeable. Therefore, we would be losing a lot of fluid and swelling all over the bodies, and that can actually, lead to extreme stress on the cardiovascular system, circulatory system, and could lead to death in something as extreme as a anaphylactic shock, which is, the reaction to some sort of allergen that we're extremely allergic to. But for most cases, though, this is actually a healthy process that helps us actually get over the infection or the injury faster if we allow it to run its course. Now, what are the 4 signs of the inflammatory reaction we talked about? Well, first thing is redness. We see redness here. Why? Because we get increased blood flow and blood's red. Heat is another of the 4. Why? Because blood circulates heat. Swelling. Why? Because when the capillaries become more permeable and we start leaking our contents out of the blood, including the white blood cells and plasma, the fluid of the blood, then that increased fluid is the swelling. And then finally, the last but probably the least favorite is pain. We actually stimulate with our chemicals and with the increased interstitial fluid released by the plasma building up, we stimulate our nerve endings pain. So again, real quickly, redness, heat, pain, and swelling are the 4 things that let us know that we're going through inflammation. Now, back to this picture here. A couple things I really like to see about this. One, we see the monocyte that followed the neutrophils around. We always have more neutrophils, so we have a bunch of neutrophils. We see the monocyte following it. The monocyte actually turns into a macrophage, okay, and starts phagocytizing or engulfing the bacteria. It engulfs a tremendous amount. We have a cell that is actually a tissue cell called a dendritic cell that kind of mimics or does the same thing as a macrophage. Whereas macrophages can be derived from monocytes, dendritic cells are not derived from monocytes. They are tissue cells. They live in different parts of our body, such as our lungs, intestines, or skin. So we would have these just naturally inhabiting our skin, and if an infection comes in, they're going to do the same thing that a macrophage. They're going to be a phagocytic cell. Okay, we also have our macrophage, such as our neutrophil. Now, one difference between what the dendritic and the macrophage do as to what the neutrophil does, the neutrophil, when it comes and attacks, it usually dies in the attack. It usually engulfs, as many as it can, and then it will die in the battle. And as a matter of fact, the dead neutrophils and the whatever it is engulfing, this pathogen, makes up pus. Whereas the dendritic cell and the macrophage, they will engulf tremendous numbers of whatever we're infected by, but then what they will do, they will actually break down what they've engulfed. They will display on what's called major histocompatibility complex proteins. They will display the broken down pathogen, and then they will go back and they'll actually get into our lymphatic system, and they will try to look for the lymphocyte that recognizes that one pathogen. Now remember, our specific defenses were trained in their education. The T cells and B cells, they were basically trained to be able to recognize one specific pathogen. So the macrophages and dendritic cells, after they come across whatever it is, they will go basically try to present that to the thing that recognizes it, so it can then clone into an army and come help kill it. Now, when they do that, we say they are APCs, which stands for antigen presenting cells, because pathogens have little markers on them, little proteins on them called antigens, and that the antigen is what the T cell or B cell learns to recognize. So these antigen presenting cells come across the antigen on the pathogen first, break it down, display that antigen, and go find the T cell or B cell that recognizes it, so we can activate a bunch of cells against it. Okay, we'll talk about that in just a minute. All right, so looking at this then, notice here's their antigens, which here that happens, these happen to be viruses, and this looks like might be representing a bacteria. They have proteins on them called antigens. Now, your normal cells also have proteins on them called antigens, and they're actually called antigenic determinants, or the shapes of those proteins, but everything has its own unique antigens. So over here in our specific defenses, we have our two major types of lymphocytes that are for specific defenses. That's our B cells and our T cells. The B cells and T cells learn to recognize specific markers that are found on the invaders called antigens. Now, here we see, even though I don't think that's a very good representation of it, but here we see something like a dendritic cell, such as this, or a macrophage such as this that has come across the invader. And what it wants to do is go find the T cell, especially something called the helper T cell, and that recognizes it, and then activate the T cell, and then the helper T cells help activate both what's called cytotoxic T cells and B cells. Now, the reason why we have T cells and B cells is because B cells release, once they're activated, once the one that recognizes the specific antigen is activated, then it clones into an army, and part of the army starts releasing these proteins called antibodies. I'm sure you've heard of antibodies. Another name for them are immunoglobulins. Okay, now these become blood proteins because this is usually being released into the blood, and then these help attach to these and help destroy the invading pathogen by attaching to them. We'll talk what they do after they attach them later. But the difference between antibodies attaching and helping kill these versus the T cells is we say that B cells do antibody-mediated immunity because they're releasing antibodies, whereas we say that T cells do cell-mediated immunity because there is a type of T cell called a cytotoxic T cell that goes directly to a cell and does a direct physical chemical attack. Now, earlier I talked about that this natural killer cell and the cytotoxic T cell did the same thing. They find cells that are infected and then they kill the cells that are infected, like we saw in this picture here. So if you imagine that this T cell, the cytotoxic T cell, is going and making the direct, notice how this is a direct physical attack and killing the abnormal cell. Especially this happens when that abnormal cell is infected by viruses, because viruses tend to go inside of cells. Now, bacteria tend to stay outside of cells, even though there are some bacteria that can go inside of cells. So since I have things that are attacking me in my body fluids, I got to have a means to kill the things in my body fluids. And since things are also attacking me in my cells, then I've got to have something that can kill the cells that are infected. So I've got these two parts of my specific defenses, but I had to have something to activate them. And again, that's where these dendritic cells and macrophages, and even something called B cells, are what's called antigen presenting cells. Okay, so again, specific defenses are lymphocytes, T cells, and B cells. I have cell-mediated, meaning they go and kill cells that are infected, and antibody-mediated, meaning they release antibodies that will attach to invaders in our body fluids. Because remember, we have cells, and then we have the material outside our cell, which is mostly interstitial fluids or extracellular fluids such as plasma even. All right, here we actually see the cell-mediated immunity, and notice what I've got here. I've got my macrophage. So again, relating it, I've got one of these cells. It's come across and engulfed our pathogen. Okay, here it's engulfing the pathogen. It takes the pathogen in and breaks it down so it can display the antigen from the pathogen. Let's say that this little thing right here is the antigen. This cell will break it down. It will form its own proteins called MHC, major histocompatibility complex proteins, and it will display what it broke down on it. Then it will go looking for the T cell that recognizes that specific antigen. Now notice, here's a T cell, here's a T cell, here's a T cell, and here's a T cell. But notice they all have different receptors that would recognize the shapes of different things. So in this case, these receptors would not recognize that antigen. These receptors would not recognize that antigen. These would not, but these do recognize that antigen. So when the macrophage comes across the T cell that recognizes that, there are chemicals that are released in chemicals. There's a generic term, cytokine. Cyto being cell, kine being chemical. Cell chemicals, basically what that's meaning. And once we come across the cell that recognizes it, basically there's a clonal expansion of the cells that recognize it. So now I have many cells that recognize this invader. And remember, these are doing what we called cell-mediated, where they go direct physical chemical attack. So we see the direct chemical attack of a cell that is invaded, because cells that are invaded will also display the same antigen that the macrophage displayed. So this will actually go and find the cells that are invaded, and then will release chemicals across to kill that cell. Now, what else will happen is, in this clonal expansion, where we're making all these cells from just a few cells here, we're making an army of cells. We're going to have the cells called the cytotoxic T cells, or sometimes they're just called killer T cells. But cytotoxic T cells that go make kill. Then we're going to keep cells around now. We had very few of them to begin with, but once we're infected, we actually make a reserve. We call the reserve memory cells. This is really what gives us immunity. We keep these memory cells in us now. Okay, so once we take care of the infection, we can't afford to keep the whole army of cytotoxic T cells in us all the time after the infection is taken care of. So there are chemicals released by things called regulatory T cells that actually cause these cells to go through this process called apoptosis, or cell suicide. So the cytotoxic T cells that killed that go through apoptosis. They die off, so we don't keep so many white blood cells in our body all the time. But we keep memory cells in case we are infected again, which if we're infected once, we will probably be infected again. But now, instead of having to run all throughout the body looking for that one or two cells that recognizes that, now we have several of them, so we can activate them much quicker. They will each clone into armies, and we'll take care of the infection again. A lot of times, we will take care of the infection again before we will even show symptoms of it. So a lot of times we say we never get the same sickness twice. The truth is we get it twice. It's just we kill it so fast we never really knew we had it. Okay, so this is clonal selection theory, showing how the macrophage, which is usually comes across the infection earlier in the infection, as we saw here. You know, the monocyte turned into a macrophage. Once the infection is there, the neutrophils were helping to also take care of it. But once it engulfed several, it then engulfed it, phagocytized it, broke it down, displayed it, found these. These usually hang out in our lymph nodes and our spleen. So they're usually hanging out. They move around, but they do hang out for periods of time in our lymph nodes and spleen. This comes and finally finds it, activates it, clones into an army. The cytotoxic T cells go and kill the infected cell. We form memory cells that hang around after the infection's over with. The cells that were used to kill it, we can't afford to keep them for every infection we have, or we would become leukemic. We'd have way too many white blood cells. So we get rid of the excess T cells by a process called apoptosis, but we keep the memory cells, which are ready to then clone again and kill this specific invader if it ever comes in our body again.